We're looking at developing bio-inspired technologies for improving the performance of future aircraft.
How we might fly better if our aircraft were more like birds.
Two main things that we're always looking for with aircraft. One is safety, and the other one is fuel economy.
There are many similarities between bird flight and aeroplane flight. Two wings attached to a body of some sort, and usually a tail as well. But there are also lots of differences, and it's the differences that we're particularly interested in to take aviation to the next stage. The wings of birds articulate at the shoulder, and so you'll notice that they can flap, but even when they're gliding along, especially on a blustery day, the wings are actually moving up and down all the time, putting in little control inputs, and yet the head and the body maintain a perfectly smooth flight path.
For this experiment, we constructed a bespoke gust tunnel, or gust generator as we call it, which is a device that throws gusts of different speeds at the birds as they glide down our setup. And when they get hit by a gust, they are recorded by our high-speed motion capture and video system.
One of the things that really surprised us was that the response was this really large wing motion. We'd expected lots of subtleties to do with the kind of small motion of the feathers, but actually as soon as we saw it we were like, wow, they're acting just like a suspension system, just like on a car when you go over a bump.
Birds don't have a rigid coupling between their wings and their body. They've got a shoulder that's always being held by a muscle. This allows them to have their wings bumped by air and have their body go in a pretty much straight line.
This happens so quickly in under 100 milliseconds. It's all just due to the mechanics of the system, without the bird having to think about it.
It makes it very energetically efficient, and moreover, it makes it very easy to implement on engineered designs, because you don't need to incorporate a controller, you don't need to incorporate sensors, you just need to make sure that the mass that you have to hold in your wing is just in the right place relative to the shape of that wing. Another major difference between bird flight and aeroplane flight, which we've noticed and we're investigating, is that on most conventional aircraft, there's a vertical tail at the back, and birds don't have that. In fact, their tail is horizontal, and it's doing a slightly different job. Some new technology for flow measurement has come along quite recently, where we can generate very many small helium-filled soap bubbles. They hang stationary, neutrally buoyant in the air, and as the birds glide through the cloud of bubbles, the action of the wings on the air stirs up the air, and the bubbles faithfully move with that air, and so you can visualize the aerodynamic mechanisms that the birds are using. What we found was that the tail is producing more lift than you would have expected.
This has implications for fuel efficiency and energy efficiency, both for small-scale aircraft and potentially for larger commercial aircraft as well. In the short term, we'd like to see these ideas applied on small-scale unmanned air vehicles, so vehicles that are about the same size as birds and needing to fly efficiently and robustly in things like urban environments. In the longer term, we could see applications in larger aircraft such as commercial aviation and passenger aircraft, where we're really interested in improving fuel efficiency and also being able to deal with gusts and perturbations.
This is ready to be implemented on small aircraft instantly. We've already made prototypes which incorporate the eagle and owl inspired hinging wing concept. And I'm delighted to say that it worked incredibly well.
We've kind of started to understand some of the ways that birds deal with winds and also save energy. But there's still a lot of tricks, I think, that we can learn to get that kind of robust, all-round, all-weather, any condition performance that we see birds achieve.